Would you rather start with some review stuff here on 6, or do you want to do the 7-1 section, clear that out of the way, and then do the review stuff?
Yeah.
Start with 7? Cool. Okay. Oh, what am I doing? This is not what I want to do here. Have this all started.
I never seen the movie and I want to go do it, but I think I had to.
All right. So 7-1, we're talking about a new integration technique called integration by parts. So remember, we introduced integration as just like anti-differentiation, right? And we saw that, hey, if we had like a chain rule for the derivative, we need a special technique to anti-differentiate that. We called that technique U sub. Remember, there are 2 other major derivative rules, product rule and quotient rule. What do we do for a problem that would have involved a product rule or quotient rule? We're going to need a new technique to be able to handle those sorts of things. That new technique is integration by parts. So remember the product rule. If I do d dx of f of x times g of x, that's f of x times the derivative of g plus g times the derivative of f, right? Right? So if I integrate both sides, I have the integral cancels out the derivative here, so I have f of x times g of x, and that should equal the integral of this side, right? Everybody's okay with that? Okay. So that's what I've written here. And I know that integral can distribute across the addition sign. So we have this. And then if I subtract the integral of g of x times the derivative of f to the other side, I have this. This is our definition for integration by parts. Usually we write these at f as a u and g as a v. So we call this the derivative, or the integral of u dv equals u times v minus the integral of v times du. So what we're able to do is integrate part of a chain rule, part of a product rule by kind of reshuffling around the product rule here. Okay, that's all this is, though, is just the product rule, antiderivative. Can you zoom in on that a little bit? Is that helpful? Yeah. Good enough? Yeah. Okay. And we're going to talk a little bit about the some hints as to how to apply this, and then we'll do like a bunch of examples. And that's going to be it for today. So there's nothing more to this other than just like practice using this rule. All right. So the key here is, okay, I have the product of 2 functions that are unrelated to each other that I can't do a u sub with. How do I choose the function to make ru and the one to make the dv? Right? This is going to be the key, is getting good at doing this. Okay? So generally, what we want to do is pick ru so that when we take the derivative, we end up with something simpler. And we want to pick the dv to be the function that's easy to integrate. So when you integrate that, it's something that's easy to do. Okay? So let's do an example. Let's say we want to find the integral of x times sine x dx. So again, we want to do the integral of u dv. That's how we want to think about this. So either u should be x or sine x, and then dv would need to be like sine x dx or x dx respectively, right? Everybody's okay with that? Now, according to our rules, what should we pick to be u? I would pick x, right? Because when I take the derivative of x, I get 1. Doesn't get a lot simpler than that, right? So dv is going to be sine x dx. And is that easy to integrate? Yes, right? So once I've done that, du dx is going to be 1, or du is just going to be dx. Everybody's okay with that? And the integral of dv is going to just be the integral of sine x dx. So that tells me v is, what's the integral of sine x dx? Negative cosine x. Okay? So now I have everything I need. I have x, I have dv, I have du, and I have v.
Mr. Cooler,
Yes.
how did you get du as sine x
Du is just dx.
dx? Oh. Yeah.
Sorry, my u's have tails, my v's don't. I know the v kind of looks rounded. If you don't like u's and v's, feel free to use other letters. That's okay. They're just names. The tradition is using u's and v's. I know it's rough if your penmanship is like Mr. Kulicki, where nothing is pointed, everything looks soft. I know. Okay. So if I put this together, I have, this should be u times v minus the integral of v du. So u is x, v is negative cosine x, and we have the integral of v, which is negative cosine x, du, which is dx. Everybody's still doing okay? So I have negative x cosine x plus, and what's the integral or antiderivative of cosine?
Why? Oh, never mind. You add it. Wait, what did you add?
So I made that a plus because it's negative and negative, right? So the antiderivative of cosine is sine. Am I done? Plus c. I got to do the Paul. I'm giving Paul a hard time because on the last test he forgot all the plus c's. Even after he wrote a note to himself at the top to remember the plus c's. So I'm going to keep teasing him about it so he doesn't make the same mistake twice.
I'm going to make it again.
Now, is this checkable? If I take the derivative of this, what should I get? x sine x, right? Can you see why we'd get that? When I do the product rule on negative x cosine x, I'm going to get x sine x minus sine x, or minus cosine x, and then the derivative of sine x is cosine x, and then they cancel. Okay. Let's try this one. Do we have an anti-differentiation rule for natural log? Nope, I don't know one either. So what are we going to do? By parts. So what's my u going to be? ln x, right? And that should be easy because can you differentiate dx? No. So there's that. Yes. So v is really easy. What's v going to be? It's x. You were right the first time. Oh, excuse me, I had a yawn coming, is why I stalled. That was right, though. And then what's du gotta be? 1 over x dx, though, right? Okay. That's everything we need now. So my integral of natural log x dx is going to be u times v minus the integral of, what was it again? Good, x, so v, and then du. Okay. And x times 1 over x is just 1. So the integral of, or antiderivative of 1 is x. And then we just have the plus c at the end. There you go. Let's try this one. Which do you want to pick for u? T squared or e to the t? Which one's going to get simpler when you differentiate? T squared, right? What one's easy to integrate? E to the t, right? Doesn't get much easier than that. Why? It's just itself.
So dv is like integrate and u is
Differentiate. Exactly right. Yes, 100%. Oh, I guess I should write dt at the end of that. Is everybody okay? Okay, so I have uv minus the integral of v du. What do you think? Do you know how to do that integral that we're left with? How do you do? U sub's not going to work.
You do the thing again.
You want to do integration by parts again? You could do it again. That will work. That's the right idea. Yeah, no, that's okay. So let's do this, though. I'm going to just do that. Everybody's okay with that? Okay. So you, yeah, okay.
If we do that, then we're going to just be able to do it again.
No, because the derivative of t is 1. I think you'd. I don't think it would. I think you'd run into trouble. All right. So this is going to equal t squared e to the t minus 2 times, and I have uv minus the integral of v du and that one is easy. That integral is easy to do. What's the antiderivative of e to the t? E to the t. Is that okay? All right. How about this one? Jack? Sure. Yeah, of course. What do you want to pick for you on this one? I don't think it really matters, right? Like either one of them are kind of going to be, don't really get simpler if you differentiate, correct? I think my instinct would tell me that I would do e to the x here and sine x dx here, but I don't think it would matter. I think you'd end up getting the same answer either way. So du is going to be e to the x dx. And v is going to be, what's the antiderivative of sine? Which one is it, positive or negative? Okay. I'm just checking because I heard two different answers. I just want to make sure because I forgot. All right. So we have the integral of e to the x sine x dx equal to u times v minus the integral of v du write it this way. And e to the x cosine x. Do you not do the antiderivative for that? I don't either. What should we do? Try the integration by parts again? Yeah. We kind of do, but there's a good thing that happens in that circle. So you're not wrong there, Paul. And the derivative, or the antiderivative of cosine is sine. Okay. So this is going to be negative e to the x cosine x plus, then we have u times v minus the integral of v du. And if you look, e to the x sine x dx, that was what we started with, right? So if I just grab my highlighter. So we have run into a circle, but it's okay. Because this is all an equation, right? All this stuff is equal to each other. Right? So just add that to both sides. Paul's really getting angry at this now. So I have 2 e to the x sine x dx's equal now to negative e to the x cosine x plus e to the x sine x, right? And then I just divide by 2. Oops, over here. And I'm done. Oh, how rude, Mr. Kulik. I wasn't expecting you to pull something like that. So hopefully the point of this is, if you're doing an integration by parts problem, and you run into a circle and end up with the thing that you started with, again, it's okay. You just move it back onto the side with the original and then divide by the constant, and we're dunzos. Oh, That is some sneaky stuff. I wasn't expecting that to happen. I know, isn't it great? Okay, so this has all been working with indefinite integrals, right? If I do the same thing with a definite integral, there's no big deal, right? All that's happening is then we evaluate uv from b to a, and we do our integral from b to a, just like we'd expect, right? So if I'm integrating this from a to b, we evaluate this from a to b, and we integrate this from a to b, right? Just like you'd expect. So let's do this one. We have the integral from 0 to 1 of tan inverse dx, or tan inverse x dx. What do you want to pick for your u? There's really only one choice. No! Tan inverse x. You can't pick the inside of some function, right? We're not doing u sub here. So dv has to just be dx. So what's v? X. And what's du? One over 1 plus x squared dx. You knew that at one point. Do you still need to know that?
Yes.
Yes. Yes, you can't forget them.
Switched up with the sign.
Yeah.
Oh, yeah. With the square root in there, or the 1 minus, or the square root, yeah.
So why would so dv is equal to dx? How does that change the dx?
You integrate both sides, right? It's the integral antiderivative of 1 is x, you know. All right. So we have u times v evaluated from 0 to 1 minus the integral of u of v, it's like u, it's not u. V du from 0 to 1. Okay. All right, so let's do our antiderivative, or let's evaluate here. What's tan inverse of 1? Should be able to do this in our head. It's a trig problem, unit circle. Tan inverse of 1, not 0. It's not 1.
Root 2 over 2.
It's not root. Those are outputs of sine cosines. It's an inverse function. You should be getting an angle measure back out of it.
Oh, yes. 90.
Not 90. It's pi over 4, which is 45 degrees. You eventually got it. There's enough guessing there.
That wasn't a guess.
Okay.
Sure, it's not root 2 over 2.
I'm positive because it's an angle measure because it's an inverse.
Wait, where are we getting this? Are we doing,
Root 2 over 2 and b.
is this from?
That's me doing that part. Yep. So that's that part. Okay, how am I going to integrate x times 1 over x plus x squared? I am going to say u sub. Great. What's my u going to be? 1 plus x squared. So du is going to be, or du over 2 is going to equal x dx. Well, I might as well do this right now, right? U of 0, U of 1. Do that. So that's going to be 1 over U du. What's that antiderivative? Close. Natural log of the absolute value, U. Now, in this case, does the absolute value really matter? No, because 1 and 2 are both positive anyways. So this is going to be minus 1/2 the natural log of 2 minus 1/2 natural log of 1. Remind me again, what's the natural log of 1? 0. So this just becomes pi over 4 minus 1/2 natural log 2. All right, I got one more example and we're done with this. Yeah, done for the day. We 7.1 anyways. All right. Next up, says prove this reduction formula. Sure you are. No. It's perfectly okay.
This is part of our chapter 9.
So cool. If
I
proving
haven't
the
written
reduction formulas on my test, I'm gonna cry.
It's not.
You'll see teardrops on my
And then
paper.
I gave up.
Paul, here's the good news, is once you've seen this once, it's pretty easy to do.
Yeah.
Yes.
In the last one,
Oh, yeah, it should be over 4. Thank you. Nope, great catch. The answer, I miscopied pi over 2. I wrote down pi over 2 and I meant pi over 4. Yep, good job. All right, so the reduction formula, sine to the n x dx equals yada, yada, yada. Here's your hint. Right? That needs to be my u and my v somehow or something. Or should be v and u. That's probably what I'd really say. So I'll just write I'll think of sine to the n as sine to the n minus 1 times sine. Because I see that there's a sine to the n minus 1 here in my u piece. So I know that, like, okay, that's got to be my u. I see it there.
Why do you think that has to do with UV?
Because this is an integration by parts problem, right? This is, integral of u dv, and this is like v times u minus the integral of, v du.
Where does the negative 1 over n though? You just ignore that kind of?
This stuff here, I'm not sure where it's going to come
Like
from.
the thing right to the left of the.
Yeah, I'm not sure where that's coming from yet either.
Okay, so just kind of
Probably,
for now.
well, it's probably going to come from the differentiation or the integration of something. We'll figure it out. I'm just looking at the pieces for some hint as to, like, how do I need to take sine to the n apart? Like, do I want to do sine to the n and dx as my u and dv? Do I want sine to the n minus 1 sine x dx? Do I want sine to the n minus 2 sine squared dx? sine to the n minus 3, sine cubed dx, you know, like, I don't know how I want to break it apart. I'm looking for a hint somewhere in there. That was my hint. It's basically telling me. All right. So what is the derivative of sine to the n minus 1 x?
N minus 1 cosine.
Cosine x sine n minus 2 x and then dx. Derivative of sine is positive cosine. Derivative of cosine is negative sine. You're getting the derivative and antiderivative rules switched around there, I think. But great question, because it helps to clarify, like what was I thinking, how was I thinking about this incorrectly? Ask if you're not sure, talk it through. It helps. Is everybody okay with how we did that? Okay. What's the integral of sine x dx? Okay. Okay, so we have u times v minus the integral, and I'll take the n minus 1 out front, I guess, of v du. I'll write it this way. Hey guys, what's the antiderivative sign again? Okay, let's do that then. My apologies. Somebody said cosine. I just went with it. And I circled back. I'm like, that's not going to give me the right sign there.
Wait, why did you do that?
Because you guys told me the wrong thing.
That's impossible. We don't make those things.
Oh.
You said it was positive cosine. It was supposed to be negative cosine. That's all. All right. Well, we're getting close, right? Let's look at what we have. Shh. I have that part correct there. I have that part correct right there. And I have this right there. What I still need somehow is I need this, this, and to get rid of that. No. No. Let's look at this pink thing that's not supposed to be there. That cosine squared. It's not supposed to be there.
Does that mean we messed up?
Nope. I'm going to use a trig identity. Cosine squared x is 1 minus sine squared x. So if I do that now, I have sine x to the n, or sine to the n minus 1x, cosine x, plus n minus 1 integral of sine n minus 2x times 1 minus sine squared x dx. Okay. Let's distribute that through here. Oops. And I'm going to have and now look, what do you notice here? It's the same thing as what we started with. Booyah!
Oh yeah.
So we're going to add
Wait,
n.
how did you factor in like the sine n minus 2 and the sine n minus 1? How did you do that?
Well, I added the exponents. So sine n minus 2 times sine squared is sine to the n minus 2 plus 2, which is just sine to the n.
Then why did you put n minus 1?
Because that's the coefficient here. I distributed like the integral symbol and the coefficient in front of it also, right? Is that okay? Okay. So what's that give me now on the left-hand side? What's the integral of sine to the n dx plus n minus 1 times the integral of sine to the n dx? What's 1 plus n minus 1? N. And what's left over here? We have sine to the n minus 1x cosine x plus n minus 1 integral of sine to the n minus 2 x dx. And what's my last step going to be? Divide both sides by n. And I think I am there. Oops. Yeah, it's because I forgot to put the negative sign there when I did it. No, this is beyond the scope of what they'd ask you to do on the AP exam. That's far too much. In fact, I have to double check, but I don't believe integration by parts is an AB exam topic, but I wouldn't be doing a good job in this course if we didn't do it. So it'd be like a minor part of the next test, if at all. Okay. So the assignment is just 3 through 17 odds. Feels like plenty of practice on this. All right, let's change gears to chapter 6 questions, right? We have about a half hour, 35 minutes or something left. Go! Chapter 6. What you got? Book problems, review problems, whatevers. Happy to do any and everything. Paul.
Can you do number 7 for the review?
Yeah,
Because I'm not gonna lie, I kind of forgot about creating stuff around not the x-axis.
okay. Okay. So let's start by getting ourselves a picture. Oops. Okay, so on this one, I did make a typo between what I did on the answers and what I did on, or what question I asked. I think on the answers I did that.
Yeah, there was a couple of those.
Yeah, I think so too. So let's just change that right now. Okay. Oops. Give me a zoomer. So I think this was one where Mr. Kulik was like writing both at the same time and then ran into a couple of places where like changed one and forgot to change the other as he was doing it. So that's my region, and I'll be rotating about the y-axis. Everybody's okay with this? First thing, let's decide washer, disc, shell. Oh boy, everybody has a different answer on this one. It's a washer problem. So again, we're rotating about the y-axis, so my radius should be perpendicular, and my inner radius and my outer radius are different. So that tells me I can use a washer here. I don't need to do a shell problem. Everybody's good with that? And since I'm drawing perpendicular to the y-axis and I'm doing a washer, it's a dy problem. So what are my bounds of integration going to be? 1 to 2. And I'll just put my pi out front because the washer is r outer minus r inner. The problem is that this radius is an x value. Well, that part is easy. R inner is just 1 for x. To get r outer, though, I need to take this equation and get x by itself. So I subtract 1 from both sides to e, the power e to both, or the exponent base e to both sides. That e is going to cancel out the natural log, and then add 1 to both sides. And that should be my setup. If you had done y equals 0, what would you use? Disk, washer, shell? Disk. Because there's no, when you rotate it around, there's no hole in the middle, right? See the white part? When you rotate about the y-axis, that's going to leave a hole through the middle of this thing.
Disk and washer are like the same thing except you just don't subtract like the inner.
Yeah, for a disk, the inner is 0. Right?
Because when I think of a disc, I think of like a DVD. So there's still a hole in the middle.
Oh.
So I don't like to think of it like, okay.
Okay. Plates and washers then for Paul. Unless your plate has a hole in the middle. Maybe you have square plates at your house. Some people have square plates. That's just weird. Jack's like, I have square plates. That weirds me out. Sergio.
How did you get E, Y to the negative 1? Is that just the
No, man, I just did algebra. I tried to get the x by itself, so I had to do exponent base e to both sides to cancel the natural log.
Oh,
Right?
you see.
I'm just doing algebra 2 stuff. Paul, does that feel okay?
Yeah.
So if you had done this as it was written, the only difference would be you didn't have that. As for how I would score something like this on the test, here's what I'd be looking for. I would say that like the setup for this is like 3 points to me. I'd want to see the bounds correct. I'd want to see, the disk washer shell method set up correctly. And then I'd want to see these individual things correct. How you're calculating the radii or heights or whatever, depending on your method. Those basically be the 3 points for that, and then 1 point for the answer when you punched it through your calc. Jack?
So I just have like a general question about like washers.
Yeah.
So sometimes I like mix up the inner and outer radius. So the inner radius is always going to be the one that's I just like mix it up.
Closest to the axis of rotation.
Okay. So what's the expectation of the outer radius? Just going further.
Yes. Yep. Yeah. It's like literally if you think about your washer, this is your axis of rotation going like right through the middle of it. Does that feel okay?
Yeah.
Sure. You tell him, Paul. Who's next? Victoria, you're always good for some questions.
Yeah, I was gonna.
Let's do it then.
No. 6. No. You said 6, right?
Say 8.
We did
Say
7.
What do you say 8?
No, there's one with the circle.
One with the circle.
6.
6.
Because you.
Yeah, so this one also is different on the answer key because this was going to be a tremendous pain in the butt for the way it was written.
Because you like subtract.
Yeah, no, we'll get to it real quick here. So what I did on the answer key and what I have here are different also, right? Yes, people that looked at the answer key? Yeah, because I just took this piece out. Because that makes this a tremendous pain in the butt to have that in there, because now you have to use like 3 integrals no matter how you're doing it, which is else stinky. So we're just going to pretend that's not in there. Is that okay, Victoria? I'll show you why it required 3 integrals in a second. But let's type this in, right? Y equals x squared minus 1. And then we had y equals 1 minus, or is it 2 minus? 2 minus x squared. And then we have the line y equals 3. All right. So we're interested in this region, and we're rotating it about this axis. So first things first, disc washer shell. Washer, I agree. So my inner radius is going to be to that function, and my outer radius would be to that function. And I'm going to be integrating with respect to which variable? X. Excellent. So what are my bounds of integration? It's that x coordinate, correct? How do I find that? Yeah, either would be okay. And do I care about like rationalized denominators or something for some like a bound of integration? No way, Jose. Don't waste your time trying to make simple mistakes, right? All right. So my R outer is this one that's opening up, and my R inner is this one that's opening down.
That's it.
And that should do her.
Just because it touches it. Our outer touches that line.
Yeah. Oh, yeah. I'm sorry. Yes. Of course. I'm so dumb. Yeah. All right. So this distance is y, right? This distance is going to be 3 minus y, correct? So that's our inner that I did. And then our outer is going to be so this distance is y. This distance is 3, so that'll be like 3 minus y, because y is negative down there, right?
What do you add?
Well, it's like a negative y, right? So this distance is like 3 minus y. Because that y coordinate's negative.
Oh, so you add a y, but it's negative.
Yeah.
Wow, that's.
Right. That length or that y coordinate is negative though, right? Down here. Right? This is like x comma negative y. This distance is 3, so if I'm talking about the distance for our outer, be 3 minus y, because it's going to be minus the negative to get you the plus, to get the total distance. Right? Okay. Let's look at why they. You still could have been able to do the problem I gave you, but if y equals 1 is a boundary now, this becomes a colossal pain in the tuchus, because I need an integral to do like this piece. I need a different integral to do this piece, And I need a third integral to do that piece. Because they all have different inner and out, or the inner radius is different in each one of those three pieces, which stinkos a lotto, which is why Mr. Kulik changed it, but apparently forgot to update the question when he changed it. So I apologize on that if you did this and were like, this is a colossal pain in the took us, and then looked at my answer and be like, why he didn't do it the hard way? What's going on? It's just I made a mistake, guys. I'm really sorry. I was trying to make it easier, and then I forgot to finish making it easier. I made it easier for me, but not for you. It's like the worst kind of mistake I can make. Victoria, are you happy though with what we did there? Okay.
It's just finding the.
Yeah. But here's the good news, right? Like, if you have this right, and you have like the form right, that's 2/3 of the points there, right? And if you have and I would even say if you have the correct function like here and here, that's a half. So you're just missing a half a point if you screw up like the subtraction, is it 3 minus or 3 plus? You know what I mean? So like, it's probably okay. What do you guys think? You know what I'm even gonna say to you guys, now that I'm thinking about this? I think on the exam I ask like to type it into your calculator and get the numeric answer. I'm gonna probably end up asking not to do that. Because what's the point if you don't get the setup correct? Right? Like it's purely like a point that you can only get if you did the setup correctly. So like why would I count all these points for the setup and then a point for the correct answer when you can't get the correct answer without the correct setup? Right? That's stupid. That's like adding extra point for doing it correctly that you can only do if you get it correct.
That's good.
Right? Like that's dumb. That makes it harder to do well. Right? Because if you make a silly mistake on the setup, you're just like, that's a point you can't get.
So would it be just set it up?
Yeah, that's probably what I'll change the directions to. I think I had listed as part A and B. And it saves you a few minutes of having to type stuff in your calculator then, right? You guys have convinced me. You made a very strong argument that none of you actually made. It just became clear to Mr. Kulik that like that's a dumb way of scoring. Yeah, it's hard. All right. Well, we got 15 more minutes. You got one for me here? Paul?
Can you explain how you did the average value for the graph?
I think I got the wrong answer there. Is it supposed to be 0?
Oh. Because I got the same answer as you, but I didn't.
Okay.
Well, I think I did.
I didn't find any zeros, I don't think. So I want the integral of 1 over 14 from -7 to 7 of f of x dx, right? So I have, let's see, that's 2 units long and 3 units high, so that's 2 by 3, but that's negative. And then I have this little guy here, that's 1/2 base, which is 1/2, times height, which is 3, oops, but that's a negative guy there. Then plus, I have this triangle, whose base is 3.5, whose height is 3.
Why does the area area.
What's that?
Like, why does taking the area of all the shapes?
Why is the area under the curve the same as the area of all these little shapes? I'm just finding the area under the curve, right? That's what an integral is.
Oh, I didn't know it was asking for that.
Well, it's asking for the average value, right? F-av is,
Oh, and and then so that's what the 1 times 1 over 14.
yeah,
Okay.
yeah, exactly.
That makes sense.
Yep. Okay. So let's see here. I guess we'll turn that into a triangle, that into a trapezoid, that into a trapezoid, that into a trapezoid. Probably should have given you the, I don't know, I hope that's right. Do that way. Okay. 1/2, 1 times 3 plus, that's a trapezoid. How do you find the area of a trapezoid? 1/2 b1 plus b2, so that's 3 plus 2 times height, which is just 1, plus 1/2, and then 2 plus 4 times 1, plus 1/2, that's 4 plus 3 times 1, plus, it's another trapezoid, that's 3 plus 6, and then that's a triangle there, that's 1/2, 6 times 1, and then plus that square, which is just all 1 squared. So I just go ahead and compute that out, whatever that comes out to be. Ugh. Seven. 4.5. 3 plus 1. So 17.5.
I think you messed up when you first typed it in.
2 times 3. Right?
6 divided by 3.
Well, I have 6 divided by.
Yeah.
I have 6, negative 6 minus 3/4. That's this one. 1/2 base times height.
Why is it divided by 4 though?
Well, 1/2 times 1/2 is 1/4 times 3
Oh.
is 3/4.
Oh, but that's 17.5 over 14. I thought 17.5 was your final answer.
Yeah. So whatever, 1.21. So you do that, it looks like something there. So those 4 x's, whatever those estimate out to be, are your values for C. Does that feel okay, Paul?
Yeah, I had just done it differently, but
Yeah, I mean,
understand why you did
like,
what you did. But that helps.
yeah, I don't even know, like, there could have been a stupid arithmetic error in here or something, like, I'm trying to draw a picture and the numbers are small and, like, it's hard to draw a straight line, and but I just geometried it out.
Oh, yeah.
What did I get when I did it over in the key? Did I make a mistake here? 39 out of 28. No, that's probably what I just came up with, right? $35 out of 29. Oh, I did it up by 14.5 also. Gosh darn it, you're dumb. That seems better. So 5/4.
I got the 1.39.
Yeah, I don't
But
know.
I mean, I feel like that's like close. Like,
Yeah,
would you like be like super picky? Like, if we got it a little wrong because like we're like.
I mean, it would be like if this is a whatever. If there's 5 points here and you like goof up the arithmetic inside of like what you're doing, but it's like one thing is wrong, it'd be like a half a point. You know, like 4.5 out of 5. You know, like it's not the end of the world.
Yeah.
It's like, yeah, all your answers are a little bit off, but it's because you know, like you said, this length was 7 when it was a 5 or something.
Yeah, okay.
You know, or you copied something down wrong or whatever. You know, like. Sorry about that, Paul. Whatever
it's
silly
good. I just,
mistake.
Like, wanted to understand. I didn't help me understand.
Yeah,
Like, why that.
yeah. So that's, I don't know why I didn't get the right answer or get the same answer here. I did something dumb. Oh, I know. I see what I did wrong. Look at this. Look at this. What is that point's x coordinate? That's negative 4.5, not negative 3.5. So that should be 4.5, and that would probably be the difference between the two. That's probably what it is. Gorsh. That's pretty dumb, Mr. Kulik. I know. Can't even label a point right. This is like algebra, pre-algebra, 6th grade or something, 7th grade. When you do points, start plotting a point. 7th grade probably, 6th grade, something like that. Yikes!
That was a hard class. Beat yourself up.
It was a really long time ago. Well, what do you guys think? All right. I'm glad to hear that, Paul. Let's go. Just FYI, the hope here is that we'll finish chapter 9 by the end of March, and then have April to do a couple of these extension topics and just spend time reviewing. So we have just chapter 9 left to do as far as AP topics go. We won't do all of chapter 9, I don't think. I don't think we're going to do 6. I'm almost sure we're surely not doing 9-6. I'm not sure about 9-5. I think we will do 9-5. I worked this out somewhere. It's probably still in the first hour one because that's where I was writing these. Yeah, so we'll do 9-1 through 9-5. We might do partial fractions here But we might do it as part of one of these other things when it comes up organically. And we'll see what else we can kind of squeeze in there. But that's the plan. Reminder, what happens next class? The test.
The test got canceled.
We gotta do them, guys.
There's no test left for seniors. They're not allowed to do them anymore.
They're not allowed to do senior tests
They
anymore?
actually said that.
Yeah, they said that.
Who told you that?
Everybody.
Mr. Guest. I'll check with him today.
I bribed it with someone.
Hush money. I think that's what
That's kind of the opposite.
See, but this is all
And-
you do.
I'm going to explain this more.